Here's an example of a performance goal. It says students will identify a function of the form y equals b to the x as an exponential function where x is the exponent and b is the base. Students will be able to substitute values for x and b to evaluate exponential functions. The focus of a performance goal is the procedure. And in this goal, students are only required to recognize that a function that's written like y equals b to the x is an exponential function. So under this goal, students are not required to understand the relationship between quantities in an exponential function. So when an exponential function is represented in a different way, such as a graph, a data set, ordered pairs, verbal description, students are not going to be able to recognize it based on the learning in this goal. In addition, this goal focuses on one procedure, evaluating exponential functions by substituting values for x and b. That's basically memorization. Now let's take a look at a learning goal. This learning goal states students will understand that exponential functions grow by equal factors over equal intervals, and in the general equation y equals b to the x, the exponent x tells you how many times to use base b as a factor. Notice the learning goal addresses the conceptual understanding of what it means for quantities to be an exponential function, that the function values grow by equal factors over equal intervals. Now students still must know that y equals b to the x is one way to represent this function, but they must understand what that means, that the exponent x tells how many times to use base b as a factor. And students who have that understanding are better able to recognize relationships that are exponential and apply that understanding. Now, when we compare these two goals, under which goal would the deepest thinking, the deepest learning take place? Well, hands down, it's the learning goal, right? Now, let me say this clearly. Procedural practice is necessary in mathematics learning. There is a time and a place for learning and practicing procedural skills. However, in general, learning goals generate deeper thinking and learning because they support developing our students' conceptual understandings that are behind those procedures and applications. Now let's compare these two types of goals to the standard that they align to. Both of these goals align to FLE 1.1, which says students are to distinguish between situations that could be modeled with linear functions and with exponential functions. A, prove that linear functions grow by equal differences over equal intervals. B, recognize situations in which one quantity changes at a constant rate per unit interval relative to another. And C, recognize situations in which a quantity grows or decays by a constant % rate per unit interval relative to another. Whew, that was a lot to read. So which one of these two goals best supports the learning that's identified in this standard?